Start. So yeah, yesterday we have seen couple of topics starting from merging, rebasing, pull request, or cherry pick. So all are used for a same concept. Merging our changes or our code from one branch to another branch, because that's the whole point of creating branches, so that we don't disturb the main branch. We'll work on our own branches, and finally when our work is done, we'll merge to the main branch. Otherwise, we don't know, right, whether the code is working or not until we test it. So directly we cannot push to main branch, and you just expect that it will work, right. So that's why the whole branching concept came, and the strategies concept came. And next we have seen stashing is where when you don't want to commit but you want to uh, switch to different branches without committing, which is not possible by default, because I shown you yesterday, when you switch to another branch without committing, it will throw error. Sorry, it will take the data along with you. So we don't want that. That's why we do stashing. And of course, this stashing works when you don't want to commit. When you want to commit, you can just simply commit it. No need to stash. You can commit and switch. So only thing is, when you don't want to commit it, but you want to switch branch, use stash. And one more thing, squash, merging multiple commits into one. The, the scenarios, like let's say I have made small changes, maybe last or multiple commits. I want, it does not look good. Just for one line change, I made a commit. I want to merge all of them as a one commit. So at the time I'll do squash. The squash command is git reset, git rebase hyphen I head tilde the number of commits you want to merge, and of course picks the it'll open the editor for you. The number of commits whatever you mentioned. So you have to pick one commit out of that. Always pick the old commit. And remaining commits, remove the pick and keep the yes. Yes means squash in that file and save it. It will be squashed automatically. And finally, conflicts we have seen. Conflicts where when multiple users, let's say multiple developers are working on the same file, same line, pushed it, but GitHub does not know what to take, because I have two changes. What to take? At the time, you will see these duplicated content in file. It will show you which file exactly have the conflict and which line exactly have the conflict. Also, you will understand it. It will show in one branch this is there, in another branch this is there. What to do? Which one to take? So you have to decide that which one to take and remove the other things and commit it. That's it. These are all the things we have seen yesterday. Today we'll close GitHub topic, Git topic. We have two major topics to cover. One small one, yeah, that we can able to see. Don't worry. Let's 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 start. Is there anything? Git clone. Yeah, I cloned it. See what I told. What is the main use of Git? What I told. When we started this topic, it will store the versions, right? It will store the versions in the form of commits. So what I told, so that you can go back to any commit whenever you want. Let's say this is the new commit, right? This is the latest. Obviously, head is here. Origin master means in GitHub also this is the main. This is the top, because we pushed this. We have pushed this commit. So currently we are in this. I want to go here. You can go. That's the whole point of Git, right? Or I want to go to this commit. It means this commit or whatever these commits does not working as expected. So I want this commit to be the main, or I want this commit to be the top head. I mean, not don't say top, just head. We can do that. That's the whole point of Git. Going back to previous versions whenever we want. That's the advantage of Git, which it provides to us. So there are multiple commands to do that. Of course, the first thing is why we go back. because the new one whatever we change it's not working as expected, that's why we go back. Maybe these four commits are not working as expected, so I want to go back. You can just simply paste the copy, sorry, commit id. There are two things we can able to do. There are two commands, reset and revert. Let's start with revert, which is an easy one. Let's say first we have to choose which commit we to which commit we want to go. This one, August 7th, this one. Remember this. What is the commit message? Update test 7. Remember this. Simple. The command is git git revert. See, this is the commit message, right? This is, if you want to change it, you can change it. Otherwise, you can just keep as it is. Did I save the file? Yeah, so I saved it. See here. The same update 7. This is where is this? This is what we wanted. See, this is what we wanted to be on top. See, it came here on top. Of course, the commit ID will change, but see the commit message and all. You know what happens? What happens is, what does it mean? I want to go back means I have to switch back to the old one and delete the new ones. No, Git revert does not do that. What Git revert does is, hey, I want the old one means it will take the old one and keep that old one top of the branch, on the head of the branch. It will make it the head of the branch. Currently, I want this, this whatever the commit message is there earlier. I want this. I want to use this. So what Git revert did is, it took the commit from there. I mean, just a copy paste. Not move and all. Just copy paste. It copied from there and kept the commit in the head, in the top of the branch. Now this will become the top of the branch. See, there are so many files missing. Let's go to here. Yeah, not here. Sorry. This is the master, right? Whichever files we have committed after that commit, they won't be visible. So now the data will be shown to you only in that commit, whatever present in that commit, because that's the latest. Because GitHub shows the data whichever present in the latest commit, right? So now the old commit which we wanted to go, that became the head now. That is the latest now. So it will show that commits data, not the other ones. Now earlier we have where is it? Yeah, earlier this is the top of the branch. Now it became to second. This is what, right? This became second. Like that, we can go back to previous version. As simple as that. So let's say I want to go back to one. Let's see. Maybe I want to go to here then now. Because these three commits are not working again. I want to go here. Now what happens? This commit, it will git revert. We're doing that, right? Git revert. This will take this commit and keep on top of this, and this head will point to this now, because we wanted this. It means this will become the tip of the branch or head of the branch. That's what it does exactly. Let's do it. Git revert. See, update test. You want to change it, commit, change it. I mean, you can change it. Update test today, something, whatever it is. Control X, save it as git log. See, this became the head now. This was the earlier, right? Update 7, test 7. This became old. So without deleting any data, git revert, without deleting any data, git revert will go back to previous versions. We'll go back to previous versions and make them as a tip of the branch or head of the branch. That's what it does. Most commonly used command when even we only use every day. Oh, the new commit is not working, what to do? Let's revert back. That's what we say. Let's revert back means let's do this. You know the old commit which is working, select it and git do the git revert and done. This will go back. The new commit will come down and the old commit will be on the tip of the branch, not top, both all are same. I mean tip of the branch where head points to it. What does it mean head points? This is the top. There is nothing after. See, this is the head. There's nothing about that. That's what about revert. Revert. That's what revert does. Got it? Any doubts here? I mean, because we have a similar other concept similarly. Just 1 minute. Just 1 minute. బయట కూడా గీజర్ ఆన్ చేయవా మేడం బయట గీజర్ ఆన్ చేయ sorry. So any doubts here before moving to another topic? It's very small, I know. So but don't get confused. It'll just take the old one. See, it's like just copy pasting. It's taking the commit from the old from the previous old history, previous versions, and keeping it in top of it, on top of it. That's it. That's what it does. Got it? So you might get it out. How the hell people remember which commit to go? Let's say my latest commit is not working. Okay, which is fine. 1 minute. This is not working. I want to go to this, maybe let's say this one. How the hell people decide that, right? We can't remember everything, right? You know how to do it? First they'll check the data in this commit, whether what's present in this commit. Then they'll decide, okay, whether this is good or not. How they check the data of the old commit? Simple. Git checkout. Git checkout, if you do branch name, let's say dev or test, it will switch to that branch. Correct? That's what we have seen. Correct? Git checkout branch name, it will switch to the branch. And you can see whatever present in the branch, obviously. Now instead of branch, if you keep the commit ID, you will go to that commit. How the hell I know? Switching to this commit ID. Now type ls. These are all the data present in that commit. Usually what we do like this. We'll check out to the specific commit. We'll check what data inside it, and if we think this is okay, then we'll revert to this commit. Like that, they'll check multiple commits, whichever is suitable for them, and they'll work on it. Like this, they can figure it out, okay, whether to use this commit or not. And you can create a new branch from here also. That is also fine. Let's say I'm in this commit, right? Git checkout -b QA. I'm just creating. So I'm in a QA branch, obviously. Now what happened? From that commit, we created a new commit. It means the data, whatever present at that point of time in that commit, will come into this branch, in the new QA branch. See, what we do generally, we create branch. So what happens? From where we created the branch, let's say from master branch or some other branch, that data will come to the newly created branch, right? Similarly here also, we are in commit now. So we created a branch. It means whatever the data present in that commit, of course commit is a part of branch only, but yeah, maybe a little old version. So whatever the data present in that commit will come to that newly created branch. Just same logic, except we are in the commit instead of branch. That's it. So that's how people check it. That's how we'll also check. Yesterday also we did the same thing. We wanted to revert back to old one. So what we did, we have the repo right in our local. So we checked. We went to old commit git checkout like this. No need to give full also, just give the starting 6. This is also fine. I mean, that's fine. Give full, that is also no issues. I mean, nothing wrong. So we went to old version, we checked the data. We have one file, so we opened the file and we checked which line and all everything. And we are good. And now what we did? We created a new branch out of it. Like this. We made our changes, whatever required changes, and we merged to master. Same thing. That's what. See, the files may be different. Here, maybe test files I created for demo purpose or class purpose, but the working is same. Command does not change, right? The situations does not. I mean, the situation may change because you are in an organization. You are currently you are just practicing. The environment may change, but situation, whatever in the commands, everything stays same. You don't worry about it. That's about revert, and of course how to check the data in the commit also. Of course that's the easy one, but yeah. Now we are in a QA branch. As I told you, not only revert, there is one more called reset. Reset is a little dangerous. You have to be careful. Of course, people use reset also. There is nothing wrong. It can delete the data. That's what I want to say. Revert, there is no data deletion, right? The commits will still present, but of course it will be little old. It will be little bottom. You can go back to that anytime. But reset, make sure you are doing correctly. So there are three types in resets: soft, mixed, hard. We will see all those things today. Git log, obviously. I want to go to this commit, or maybe this one. What I'll start with git reset hyphen soft. Let's see what happens. Nothing. See, it uncommitted those changes. See, this is a commit, right? I committed the changes. It uncommitted those changes. I mean, once it took them one step back, or it brought them one step back. Now you can do it again. Change the files. No worries. You can able to do it. Blah blah blah. And we commit again. So git reset soft. By now you might understand. When you are committed already, but you want to uncommit it, so that you want to make some more changes. So at the time you can use git reset soft. I committed again. See, committed. As simple as that. Got it right. Now it became a new commit. Now let's say that's about soft. I mean, so what happens soft is when you give git reset soft the commit ID, it will uncommit that. It means whatever the changes you committed in that commit, you modified in that commit, those changes will be uncommitted. It means the changes are present. They don't delete it, but they will be in a staging area. So staging area to commit to push, right? So from commit it will take one step back to staging area. That's what it does. Git commit soft. Let's do git reset soft. Let's do mixed. Now what happens, earlier git soft, what it did, it took back one step, right, from commit to uncommit to staging. Now here it will take two steps back from commit to unstaging. Let's say git status. It's a red symbol. It means it even took out of the staging area, the first place. Git's not even tracking that anymore. That's why. See here, unstaged changes after reset. Commit again. It'll see soft took you one step back. This took you two steps back. Got it? Like that. This took you two steps back. So what's happening here is it unstaged your files. Of course, you want to add it. Git add. Obviously, you know these things. Git hyphen new one. Git log. See, new one commits are there. Obviously, that's what mixed is about. It will take you two steps back. So git soft, what it will do, if you give a commit, it will uncommit the changes. I mean, it will keep in staging area, but just one step back, right? So before committing, it will be in a staging area. So one step back. Mixed, git reset mixed, two steps back before committing, staging and unstaging, right? It took you two steps back to unstaging. That's what it does. So when you don't give anything, let's say when you forgot to give the type git reset, the commit ID, By default, mixed is the one which will apply. So same commit, but you forgot mixed. You forgot this type, what type you want to add. By default, mixed, it will take mixed. See, it will update unstaged files after reset. It will take mixed. So don't worry about it. Here also, as of now, there is no data loss. Then what the hell is data loss? What we are going to see now, that will have the data loss. Let's say this is the test one commit I want. Correct? On top of that, we have 1, 2, 3, 4 commits, right? New one, test, blah 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 something. Let's see what happens now. Git reset hyphen hard. This is a dangerous command. See, test one. Uh, Earlier, what we have seen above test one, there are few more commits. See, they are all gone. Data is gone. That's it. That's why it's dangerous to use. Do not use hard until someone says to you, means until there is no other option. Okay, everyone decided to use the reset hard, then only use it. And of course, take an approval before doing it. Otherwise, it is a blame game, right? Everyone will blame you. So don't do that. See, here is where the data is gone. Now head is, of course, the head is pointing to test one commit because CB, that's what we told. CB 5858. On top of it, there were 4 commits. All are deleted. Gone, they're gone. We cannot get it back. It's over completely. That's about git reset hard. You got it? So these two are the options. Revert and reset to go back to previous versions whenever you want. Whenever you want. Of course, most commonly used is, as I told you, revert, because there is no data loss. It's pretty straightforward. Git revert the commit ID, that commit ID will be on top. The old commits will just go down. That's it. There is no data loss. Mixed, I mean git reset. When people use in git reset soft or mixed, when they committed it but they want to uncommit the changes again. At the time, mixed or soft they'll use. Hard, when they want to delete the data completely. Hard. So always make sure you use revert. In worst case scenarios, you cannot do anything, then only go for reset hard. Reset soft or mixed, you can use it regularly. I mean, but of course, you committed it. You forgot to make one more change. Git reset soft. It'll uncommit, right? So you can work on it again. Same thing. So don't worry about it. That's how you use reset and revert. Any doubts? There is one small topic. It hardly takes 2 minutes. With that, we'll close the GitHub. But before closing, any doubts? Any doubts? Anything? Yes, these are all present all in the document already. Don't worry about it. So yeah, if no doubt, then we'll go to the last topic in Git called tagging. Tag. Tagging we use for tagging a commit just to identify. I mean, just to for our purpose only. See, we cannot remember the commit ID, right? As well as we cannot remember the commit message also. See, I just gave for demo purpose. I gave test one, test two, test three, blah blah something. But we don't do that in organizations. It will be a different ticket numbers, bigger descriptions. It's difficult to understand. And let's say we deploying today. So which commit we are deploying? Is this one or this one? We don't know. So at the time, what we do, we tag it. We tag the commits. So based on the tag, we can able to identify. Uh, okay, what has been used, what is working or what is not, something like that. It's just making our life easier. That's it. So we just tagging it. We tag only commits, not the branch or anything. We just tag the commits. and that's it. Let's tag this commit. Let's see. Nothing real, just assigning a tag. See, when you go to any, let's say you joined a company, why they gave you the email ID or user ID or everything? Just to identify you, right? For uniqueness. Otherwise, they can't say use manager email ID, something like that. Just for our reference, just for references. They'll give, similarly here also tag, we are giving that for reference. There will be employee tag, right? Why the hell they need it? To identify who's who. Here also we are applying tags to commit so that we'll identify what is what. On what purpose we use tag? Mainly so far, I mean, I have also used only one purpose. Today, let's say we are deploying this commit. Let's say we'll tag this commit before deploying, so that in future, let's say after 2 months or 3 months, we want to see what commit we have deployed on August 8th to production. We don't know, right? We don't remember without tagging. But if let's say there is a tag, something called meaningful tag, deployed on August 8th or something, then by looking at that, you'll identify, okay, this is the commit we deployed on August 8th to the production. Solely for that purpose, we are using the tag. Of course, there are multiple purposes. You can tag any commit for your purpose, but for release purpose, release means deployments, deploy. So to identify what we have released, uh, we are just tagging it. See what happens is, it happened to us also. After a few months later, there was one more issue in one of the in application, but it was not recently developed. It was developed very old. I think, yeah, as I told, right. So we want to find out when this was committed. We got a rough idea, like, in this month it's committed, in this month it's committed, and we did git log and we went to that month commits, and we found out there was a tag, with the release number or something. We release date. I'll show you how it looks like. Based on the tag, we find out, okay, this is the commit we deployed, and we checked out to this commit. We checked the code. We created a new branch out of it, fixed it, merged it to master, and deployed it again. That's what the tag is used for. Simple as simple. Git tag. The command is very simple. Hyphen a. What is the tag? Usually, as I told you, right, release dates. How it looks like is 2025.08.08. I think it's correct. This so that you'll remember. Okay, August 8, 2025, we deployed this commit or something like that. Tag for release. Maybe August release. What is the commit ID? Paste it. That's it. How do I see it? Go to git log, you will see it. See, this does not add anything extra, just for our identification purpose only. Got it? See, like this, we can able to tag. That's it. That's the only. You can tag anything. I mean, not like this, purposefully. Add your name, whatever it is, it will take it. You can see git tags. Sorry. It will show you all the tags. Of course, you cannot identify anything by these tags. I mean, what inside the data? Let's say you want to see what's inside this. Git. Sorry. Git tags. Git show. It will show you what has been updated or what has been committed in this, tag. See here, what's happening is this tag is assigned to one commit, right? And see, it will show what has been done in that commit. New files created. Some are in the test file. Some lines are removed. Again, some lines are added. Blah blah blah. All this information. See, it will show you. Got it? Let's say I want to remove the tag. I don't want it anymore. Copy it. Git tag hyphen d. Sorry, d. My bad. Removed. Let's see the log. See, no tags anywhere. It's gone. As simple as that. But I just told you, we're just assigning the tags for our reference only. It does not bring anything extra. Got it? That's about tagging. We tag it and just for our reference, we remember it so that we remember it. Got it? So with this, we closed our GitHub Git topic. I mean, so until what we did so far is we managing the code, source code using Git and GitHub. As I told you earlier, Git is the client, GitHub is the server where we store that code. So with Git, the client, we manage the server, the repositories and everything. This is very very important actually. I mean, this is the starting point of DevOps. So now until now, what we did is we just managed the code. Next thing is the code is ready now. What's next? What I have to do with the code? I need to test it, build it, deploy it or something. Let's continue like that. So there won't be any class tomorrow, so we'll continue from Monday with a new tool. But yeah, the continuation will be, now imagine the developer made the code ready. What's next? What we have to do next? That we'll discuss on Monday. Okay. So, but yeah, I shared the documents already in the Telegram channel. So please download them and go through it, practice it. Okay. Don't miss that. I think I already shared the Linux document also. Go through that one as well. All right. Any doubts so far? In general, Git or in Linux or uh, today's class also. Any doubt? So if no doubts, I think yeah we can close the call. We'll meet on Monday. All right. Until then, keep practicing. Happy weekend. Yeah. Bye. Bye all. Have a nice day. And again, download the documents from the Telegram channel. All right. Bye.